The journey of laser and LiDAR, from Einstein's theoretical conception in 1917 to contemporary innovations, is a fascinating tapestry of scientific and technological advances. Einstein's proposal on stimulated emission paved the way for the development of maser in 1953 by Charles Townes' team at Columbia University, marking the first practical step in the application of this revolutionary theory. The 1960s saw significant advances, with Theodore Maiman of Hughes Aircraft Co. demonstrating the first laser in 1960 and the subsequent construction of the first LiDAR prototype by Hughes Research Labs in 1961. The laser's ability to measure distances with unmatched accuracy was proven in 1964 by NASA's Goddard Space Flight Center, led by Henry Plotkin, when measuring the distance to an orbiting satellite. The year 1965 was marked by two notable innovations: the development of laser altimeters in the United Kingdom and the introduction of the first airborne laser profiler for topographic mapping. This latest innovation comes from a collaboration between Spectra Physics Co. and Aero Service Co., opening new frontiers in accurate mapping of the Earth's surface. In 1968, George D. Hickman of Sparcom Inc. pioneered the first bathymetric LiDAR flight over Lake Ontario. This milestone led to several subsequent developments, including the founding of Optech Inc. in 1974 by Alan and Helen Carswell, which became a leading developer of LiDAR technology. The 1970s and 1980s saw the emergence of several companies and innovations, such as the production of the Avco airborne laser in 1979 and the Larson 500 from Optech Inc. in 1984, the latter creating the first hydrographic chart derived from an aerial LiDAR. The integration of GPS into LiDAR surveys in 1985 by the NASA team was a significant advance, improving the accuracy and efficiency of these systems. The 1990s was a period of exponential growth for LiDAR technology, with Optech Inc. developing the ALTM 1020 in 1993 and collaborating with the Swedish Defense Research Center to develop the airborne flash system. The same year also saw the launch of the revolutionary Shoals Top Bathymetric LiDAR by Optech Inc. The beginning of the 21st century was characterized by acquisitions and strategic partnerships. Leica Geosystems incorporated Sierra Technologies and Azimuth Co. in 2001, expanding its portfolio of LiDAR technologies. Over the past 20 years, LiDAR technology has experienced remarkable evolution, with significant advances in terms of accuracy, efficiency, and diverse applications. Since 2003, the industry has seen the emergence of innovative products and the strengthening of strategic partnerships, pushing LiDAR into new frontiers. 2003-2006, expansion and improvement of aerial LiDAR. In 2003, Optech Inc. launched the ALTM 2033 and 3033 models, which stood out for operating at heights of up to 3,000 hours with frequencies of 33 kHz, revolutionizing aerial topographic mapping. In the same year, the Shoals 1000 bathymetric LiDAR was introduced, with frequencies of 1,000 Hz and 400 Hz, significantly improving the accuracy of measuring sea depths. Fast forward to 2004, Optech released the ALTM 3100, offering operating frequencies up to 100 kHz, a milestone for large-scale aerial mapping. In 2005, David Hall's rotating LiDAR in the DARPA Grand Challenge became the precursor to Velodyne's HDL-64 LiDAR, which would prove crucial in the development of autonomous vehicles. In 2006, Optech's ALTM Gemini, with its multi-pulse technology reaching 167 kHz, expanded the capabilities of precision aerial mapping. 2007-2010, advances in mobile mapping and bathymetry. The year 2007 was marked by innovation in urban mobile mapping with Optech's Lynx mobile mapper. This system captured LiDAR data at a 360 ALO amplitude, transforming the mapping of urban infrastructures and highways. In the same year, Leica Geosystems integrated medium-format digital cameras into its ALS systems, an innovation that combined imagery and LiDAR data for detailed mapping. In 2008, Regal launched the VQ-480 airborne LiDAR, adapted for helicopter platforms, ideal for mapping corridors and restricted areas. Still in 2008, the VZ-400 terrestrial LiDAR expanded the range and precision in terrestrial topographic surveys. In 2009, Leica Geosystems introduced the ScanStation C10, a terrestrial laser scanner with advanced panoramic capabilities, ideal for architectural and heritage surveys. And in 2010, Regal launched the VZ-1000 and the airborne VQ-580, both notable for their range and precision, essential for engineering and urban planning projects. 2011-2014, LiDAR for RPA and bathymetric expansion. In 2011, Regal launched the VZ-4000, designed for surveying and open pit mining, expanding the use of LiDAR in industrial environments. Optech introduced the ALTM Aquarius system in the same year, aimed at shallow water bathymetry, crucial for environmental and coastal studies. Fast forward to 2012, Optech's Altium Pegasus HA500 stood out for its use in mapping large areas, essential for regional development projects and environmental monitoring. In 2013, Leica Geosystems launched Pegasus. 1. An innovation in mobile mapping with camera integration, facilitating urban planning and infrastructure management. In 2014, Regal developed the VueX1 for RPAs, UAVs, and introduced Recopter, an RPA designed for LiDAR, opening doors for aerial inspections and agricultural monitoring. 2015-2018, personal LiDAR and technical advancements. Regal introduced the VZ-400i in 2015, standing out for its real-time data acquisition and georeferencing, ideal for geological and archaeological surveys. In the same year, Hexagon Leica Geosystems launched Pegasus Backpack, a personal LiDAR system that revolutionized indoor mapping and infrastructure documentation. In 2016, Teledyne Optech introduced Eclipse, a LiDAR system integrated with an aerial camera, optimized for environmental and large area surveys. In 2017, Hexagon Leica Geosystems' introduction of the SPL-100, a single-photon LiDAR, represented a breakthrough for large-scale aerial mapping. In 2018, Teledyne Optech launched the Altium Galaxy T1000, notable for its high operating frequency, transforming aerial mapping of large territories. 2019-2023, continued innovation in hybrid sensors and LiDAR for UAV. In 2019, Hexagon Leica Geosystems introduced the Leica City Mapper 2 system, combining oblique imaging and LiDAR, essential for urban planning and city mapping. In the same year, Regal launched the Mini VueX2 UAV LiDAR, improving efficiency in UAV-based surveys, crucial for infrastructure inspections and environmental monitoring. The period from 2020 to 2023, although specific details are not available, has likely seen continued advances in LiDAR applications, from autonomous vehicles to urban mapping and environmental monitoring, reflecting a trend of constant innovation and increasing applicability of this technology. This analysis of the evolution of LiDAR demonstrates not only technological advancement, but also the growing diversity of its practical applications, reflecting its fundamental role in shaping the modern world.